good, whatever time of day you are watching this video at. For me, it is the afternoon. I mean, some days it might be later. Today, I want to discuss some early easy level calculus. This is going to be specifically, I want to talk about the fundamentals of a derivative and also some proof for the power rule later on. But essentially, this first part is going to be describing what a derivative is really like in terms of limits. So you see here, I drew out this little graph. I probably should have specified what the graph actually meant here. Here we go. Let's just quickly describe here that this graph is going to be the graph of f of x. I'm going to say here that this is going to be equal to x squared. So let's get started. We have this graph here, and let's explain some terms here. So we see this x right here is going to be corresponds to this f of x, and essentially f of x is the point at which the function is equal to x. H is the distance between our x point right here and this other point, which we'll denote by x plus h, because creativity in mathematics is very important. And then, showing mathematics even further creativity, is the point that corresponds to x plus h, the f of x point that corresponds to it is f of x plus h. How creative. So, what's the point of me showing you all this? Well, say we want to find the derivative always being everyone will say, the gradient at a certain point, at a point on a graph. Let's say here that we want to find the gradient of the tangent point when at this point. Let's say this point is halfway between x and x plus h. Straight lines are for nerds. Straight lines are for... So, how do we find this? Well, someone might be, then we don't really know what x or x plus h means, so we could find the slope of this line, and if we were to decrease the distance between these points, decrease our h value to 0, then this line, the secant line, would become a tangent line. Let me explain this. Basically, we decrease the distance between the points to here and here, decrease it to here and here, decrease it to here and here, and eventually decrease both points to just being on top of each other. And each time you get different lines. So it's gonna be this line, eventually that line, the tangent line. And to explain all this, now graphically it's easy enough to understand, but let's say we want to explain this function through, analytically speaking, through an equation. Well, that's easy enough. We use a limit. Say here that the limit as h approaches 0, because, well, our h value, the distance between the 2 points, is decreasing to 0, is going to be of f of x. It's going to be equal to the limit. Let's expand this out to, we can actually expand this out to the slope formula if we want to find the tangent line. So this is really going to end up being f of x plus h minus f of x over x plus h minus x. So that will cancel out down here, leaving us with f of x plus h minus f of x over h. Okay, simple enough to understand. So that's simple enough to understand. So now that we have established that, let's say we wanted to find let's say that this mysterious point between the graphs, let's say we want to find it when x is 2. Well, okay then. Let's find it out then using our equation we have just created up here. I'm just going to scroll down a little bit. Right there should be fine. I'm going to use a different color. Let's use red. So instead, we're just going to repeat this quickly. The limit as h approaches 0, but instead of finding f of x, it's going to be f of 2. It's going to be f of 2 plus h minus f of 2 over h. So logically speaking, we should just continue down. What's f of 2 plus h is really just 2 plus h all squared, minus f of 2 is really just 2 squared. Should never really forget this. But I'm not a real mathematician, so, well, Sort of am. I mean, I'm close enough to a real mathematician. I do math. That's the drop qualification. Who needs degrees? So we have 2 plus h whole squared minus 2 squared over h. Let's expand this out a little bit to 2. Instead of 2 plus h whole squared, we can instead say here, 2 squared plus 4h plus h squared minus 2 squared all over h. Let's see. Now, obviously, if you're actually solving limits analytically, the first step is to plug in zeros, but you plug in a zero, anything divided by a zero, it gets rough, so we don't like doing that. So let's just cancel things out. See if we can get rid of that h. So 2 squared and 2 squared, that will sort of cancel out. So instead, we can actually adjust this one down to the limit as h approaches 0. And hey, we can pull out an h here. So instead of 4h plus h squared, we can instead make it h times 4h plus h for h. Those will cancel out. Now we can plug in h for 0, meaning that 4h plus, or it's really going to be, not really 4h. Wait, did I say 4h? Guess I'm not, most of my brain's not working right now. That's alright, though. That's alright. It's going to be 4 plus h, not 4h plus h. That doesn't make sense. But so 4 plus h, or 4 plus 0, equal 4. So the gradient of the line when f of x is 2 is going to be 4. Or, in other words, the derivative when x is 2 is 4. But most people who are familiar enough with calculus will be familiar with a little rule that you can really, something that's significantly easier to do than all of this, and that is quite simply, instead of using limits and all, we can, like most people will instead of using limits, because that's a lot of work, even for a pretty basic question, instead they'll use up the power rule. If you're not familiar with what the power rule is, it's equals x to the nth, then your derivative of f of x, that's going to equal to nx to the n minus 1. So if you apply that one, it's going to be x squared. So we take the n, in this case it's going to be 2. It's going to be 2x to the 2 minus 1, or 1, or just, really, it's just going to be 2x. So, simple enough, but then if you're curious, like I am all the time about this type of stuff, is, well, how do you jump from doing this, or doing this x to the nth power rule, but how do you jump from limits to power rule? Well, if you're curious like me, then you get to go, well, you'll have fun in this second part, and I'm going to go with yellow this time. So let us set up our limit this time, and instead of we're just gonna file for x squared in general. Not gonna solve for any particular value of x. So say the limit as h approaches 0. Yes, you can see how organized I also am with math, because organization, kids, it's very important in math. So you should aim to be just as organized as I am here. So limit as h approaches 0 for f of x. This case is going to be x squared. It's going to be x plus h squared minus x squared all over h. Well, we can simplify that down to, or not simplify it, expand it out to x squared plus, that's going to be 2hx. Yeah, it's going to be 2hx minus x squared over h. So we're going to cancel it again. Then it's going to be 2h over h. So the h's are going to cancel out, meaning that the limit as h approaches 0 is going to be, for f of x, going to simply equal 2x. And hey, what do you know? That's that. But, I mean, this is all fine and dandy, but this doesn't really solve the real problem here, which is, it doesn't really solve a power rule. We only really explained why why the derivative of x squared is 2x. So I mean, but let's just take this a little step further. We gotta do something very complicated first, though. You see, we gotta make this 2, or not 2, x squared, and we gotta make it something more generic. Now, stay with me here, guys. It's gonna be very complicated what I'm about to do here. We gotta take that to there. Very careful. Instead, we're gonna make that. Gotta click the pen there. I'm very smart, you know, very intelligent here about, you know, because most people don't know this, but erasers can be used as pens with determination. So, instead of taking the x squared, instead we can make that x to the nth. Ooh, how complicated. We've just done this here. Okay, so basically by doing that, we've basically just made this into a much more generic term. That's x to the nth is just a generic term. N can be any integer, but it's not changing throughout this. Just remember, n will not be changing throughout anything we do here. So now that we have our function, we can now start doing our limit. So set up our limit like before, limit as h approaches 0, but instead we're gonna say x plus h to the nth minus x to the nth over h. Let me clean that one up a little bit. So there we go. Now, so the next step is actually going to be to expand out the x plus h to the nth. Now, to those of you who have taken a pre-calculus class or any algebra 2 class really, or you should recognize this, and that is being that to do this, we're going to need to use some binomial expansion. So we can simply take there that x plus h to the nth going to be the equivalent of saying and sigma k being just the number that's going to increase every time. It essentially just helps us keep track of like which term we're on. There to and choose k. Explain this later how this comes into all this. To x to the k times h to the n minus k. So I realized that my h's look a lot like n's. This is gonna get confusing if I don't really try to make sure that this is well defined here. But okay then, how does this help us one bit? Well, first of all, I guess I should probably explain what n choose k is really gonna be. Essentially, what we're gonna do here is n choose k is essentially shorthand for this is gonna be our coefficient here, and oh my. Let's write this in a different color too. What color are we not using? Like purple. Yeah, I like purple. Did I do it one right? There we go. We're gonna see here that our choose k is gonna be equal to n prime over k prime times n minus k prime. Yeah. Okay, and basically whenever we do it, n is always going to be equal. Remember, n is always going to be equal to our coefficient, to our whatever the exponent up there is. Now we can't really do too much with it. No, we can't really do too much with this yet. But let's just solve this out a little bit. We're not gonna now. See, we can't expand this out to its maximum potential because that would take forever. But you know what? Let's just expand this out just a little bit. Just enough to where we can get the basic gist of what's happening here. So, let's gonna have ourselves the limit as h approaches 0. And instead of our x plus h to the nth, let's expand this out. So, let's just expand this out to I'm only going to expand this out to a couple of terms. So, the first one's going to be k minus 1. So, it's really good. So, the first one's just going to be when k0. It's just going to be this is going to be over h. So it's going to sum out to x to the nth. Well, it's going to be times h to the 0th. So it's just going to be times 1. Okay, then. It's going to be plus. Oh, wait. Can't forget our little n choose k here. X to the nth. Plus x to the nth minus 1. Times, times simply, well, wait a second. we've made a mistake here. Let's see. Sorry about this. It's the n minus 1. That's going to be times h to the, like, 1 power, or it's not going to be times anything. Sorry, I haven't really done binomial. Binomial is not something I use every day. Sorry about this one here. Alright, what did I write down? What the hell did I write down here? There we go. This is why we write things down, kids. Because you never know when you're gonna make a mistake like that. For one. Sometimes. Okay, so really we're gonna start off with K here. So really, the first thing we're going so now we can actually get started here with a couple of things here. So first off, it's basically gonna be like n choose k of x to the nth minus 1 times h to the k. I don't really know why I do this shit. X to the nth times k to the 0. Wait, let me just see here. Okay, here we are. Okay, then. Sorry, guys. I'm just an idiot. Sorry, guys, for being an idiot there for a second here. Basically, we're going to have here... Basically, if we expand a binomial theorem, the first thing... Basically, what we're going to have here is it's basically going to be x to the nth plus... Now, the reason why it's going to be... The reason why this first one's going to be... the reason why we're going to first start off with just nx to the n minus 1... Now, some people might be wondering why we're going to be doing this first. And the simple reason is because, remember, k is going to be equal to 1. So if we actually plug all this in, like, let me just solve this out again quickly here. If I actually plugged all this in here, if I actually did n choose 1, it's going to equal to n prime, which at this point, we don't really know what n prime is. N prime over k prime, which k prime is really just going to be 1 times... Well, so it's just going to be 1 times n minus 1 prime. Yeah, n minus 1 prime. And this is essentially just going to be equal to, well, this is all just going to essentially be equal to n, essentially. So that's why we're just going to leave it like that here. But then past this point is when we end up, but then past this point is essentially when we don't really, like, let's just solve it up to, say, I'm going to solve this to just, to the second one, actually, to a little bit longer, actually, so, plus, is going to be another, like, n choose 2 times x to the n minus 2 times, like, what, that's going to be times h squared. I'm going to leave it at that for now. And then, just going to be minus x to the nth. Now, first of all, let's just cancel those terms out because I really don't want to deal with those terms because we don't really want to deal with terms like that. We don't really want to deal with any x to the nth terms. And now then, let's just go down to seeing how this looks now. That's going to get chaotic up there. Limit as h approaches 0 times is going to be nx to the nth minus 1, which, if you've noticed, well, some of you might be able to notice where we might actually be going with this. H plus, like, just 2 times... Okay then. Well then, now then, the only part where we have to do is just worry about the h. Now we can always take the h out of the equation. The h is basically we can take the h, eliminate this h out of here. So it's just gonna be we rewrite that one. That one's just gonna be limit h approaches 0, h times n to the x to the n minus 1, no h this time. So we're going to be nx to the h minus 1 plus n choose 2 times x to the n minus 2 times h, and so on and so forth. Don't really guess I ran out of room on that one. Over h. Our h's are going to cancel out. And now, at this point, this is actually where we're going to go back all the way to the beginning here. All the way back to the beginning is when we can finally say here that x to the nx to the n minus 1 plus n choose 2. You might be wondering why I haven't solved this out, and now you're actually going to get to see why. The n minus 2 times h, so on and so forth. You can continue this one out to n choose 3, x to the n minus 3 times h cubed, but it doesn't really matter because h is going to be 0, and if h is 0, then that term doesn't really matter. So, and you say here that our derivative of f of x when it's x to the nth is going to be equal to nx to the n minus 1. Sorry if that was a little confusing there in the end. Haven't really done I'm a little rusty on binomial theorem. It's a good chance to brush it up though. Yeah, so essentially I hope this helped anybody who is as curious about this as I am. If you want me to explain any other things, then I can always explain then I would love to hear it in any comments below. Or maybe you guys, if you want to, you could, I'm pretty good. I do know some actual definitive proofs for the trig functions for calculus as well. Really anything in math, I'm always up to explaining these different proofs on why it works like this. Hope this reinforced the concept of why we do the x of y, the power rule actually works in general, and also why a derivative is the way it is. Yeah, so see you next time, guys.